Welcome to the next session, my dear friends. In the previous session, we have discussed about the concepts related disposal of sewage effluent. In this session, we are going to solve the questions of the previous year from the disposal of sewage effluent. So, topic name is 7.2 disposal of sewage effluent. Here, the first question, GATE 1999, 1 mark. The minimum dissolved oxygen content in ppm in a river necessary for the survival of aquatic life. Already I have told you. So a minimum DO of 4 ppm is needed for aquatic life to survive. So the answer is 4 ppm. Second question. GATE 2003. Two marks question number 2. It is a match the following question. List 1 characteristics of sewage. List 1 is characteristics of sewage. And list 2 allowable limit. List 2 allowable limit in mg per liter. So choose the correct sequence. Select the correct answers. A is BOD 5, B is COD, and C oil and greases, and D total suspended solids. Allowable limits 1 250, 2 30, 3 20, 4 10 5 3, 10 5 and 3. So these are the values. So we have already discussed. So what are the limits of different compounds? Okay, different compounds when we are sending it as an effluent. So what are the limits? So BOD, it should be 20 or 30. So two options are given. Leave it aside. So see after rest of them, observe rest of them. COD. So what is the limit of COD we have discussed? What is the limit of COD? What is the limit of COD? What is the limit of COD? It should be less than 250. For both, it should be less than 250. What is the limit for oil and greases? It should be less than 10. What is the limit for total solids? It is 100, but no option is given here. Okay, I think some option mistakes are there. So let us see the options first. From options we can eliminate the answers. The options are like this: A, B, C, D. A, B, C, D. So the options are 2542, 2542 and 4164, 4164 and 3142, 3142 and 2163, 2163. So for B it is 1. So here it is 1, here it is 1, here it is 1. For C it is 4. So for C, here and here are 4. So if you take the intersection, so this is the answer. So this is the answer. For A, they have given it as 20. So they are treating it as domestic waste. Okay. So this is for domestic BOD, this is for industrial BOD. So both are answers. But for A, if you see 2 and 3, both are there. Here 2 options are 2, 1 option is 3. We don't know which one to choose. So for total suspended solids, what they have given 2. So actually this is not 30, this is 100. I think there is some error in it. Okay. So 3142 is the answer. That is question number 2. So let us discuss the question number 3. GATE 1997 1 mark. GATE 1997 1 mark. The sag in the dissolved oxygen curve results because option A, it is a function of rate of addition of oxygen to the stream. B, option B, it is a function of rate of depletion of oxygen from the stream. Option C, it is the function of both addition and depletion of oxygen from the stream. Option D, the rate of addition is linear but the rate of depletion is non-linear. So here option number C is the appropriate one because the oxygen sag curve is coming out of the depletion curve and addition curve. So out of these two curves the sag curve will develop. So that is why it is a function of both depletion and addition of oxygen to the water. Okay, that is option number C. It is a function of both addition and depletion of oxygen from the stream. That is the answer of question number 3. Question number 4. GATE 2005 2 marks. GATE 2005. GATE 2005. Question number 4. In a certain situation, wastewater discharged into a river mixes with the river water instantaneously and completely. Following is the data available. Wastewater DO is 2 mg per liter, discharge rate is 1.10 meter cube per second, and river water DO is 8.3 mg per liter, and flow rate is 8.7 meter cube per second, and temperature is 20 degrees centigrade. Initial amount of DO in the mixture of the waste. Initial amount of DO in the mixture of the waste. Initial amount of DO in the mixture of waste and river shall be. Okay. So what is the given data? What is the given data? Here a wastewater having some properties. So wastewater QW is equal to 1.10 meter cube per second. Wastewater is 1.10 meter cube per second, and DO, dissolved oxygen, is 2 mg per liter, 2.00 mg per liter. Okay, and river water, so let us take this as DOW. River water QR, Let us take the discharge of river as 8.7 meter cube per second. 8.7 meter cube per second, and DO of river is 8.3 mg per liter. So they both mixed. So that means the wastewater stream has mixed with the river water. So this is wastewater. So it has mixed with river water. So at this downstream, what is the DO mix? Is asking what is the DO mix. So DO mixture is nothing but QW DOW plus QR DOR by QW plus QR. Simple. It is a very simple question actually. So they are asking mixture, DO mixture of the wastewater. So simply doing this, we will get the answer. Question number 4. 2 into 1.1. So this is 1.1 mg meter cube per second into DO 2.0 mg per liter plus 8.7 meter cube per second multiplied with DO 8.3 mg per liter by QW is 1.1 meter cube per second plus 8.7 meter cube per second. Then we will get it in mg per liter. So the value of DO mixture in mg per liter is 7.6 mg per liter. 7.6 mg per liter. This is the answer. Okay. This is the answer given for 2 marks. Very simple question. So next question is 2014. 2 marks, set to 2. 2014. After 2005, in 2014, after 9 years, a question came from this topic. So 2014, 2 marks question, set to 2. The question is like this. A wastewater stream flow rate 2 meter cube per second, ultimate VOD 90 mg per liter is joining a small river, that is flow having a flow of 12 meter cube per second and ultimate VOD is 5 mg per liter. Both water streams get mixed up instantaneously. Both water streams get mixed up instantaneously. Cross-sectional area of the river is 50 meter square. Assuming the deoxygenation constant K is 0.25 per day and the BOD in mg per liter in the river water 10 km downstream of the mixing point is. A very nice question actually this is. Let us extract the data given. What is the data given? So wastewater. For wastewater QW is 2 meter cube per second and BOD ultimate L0, let us take this as L0, 90 mg per liter. Okay, is joining a river, so river water QR is equal to 12 meter cube per second, 12 meter cube per second and L0 of this is wastewater, L0 of river. L0 of river is 5 mg per liter. 5 mg per liter. So cross-sectional area of the river. So cross-sectional area of river is 50 meter square. 50 meter square. And deoxygenation constant KD 0.25 per day. KD is given as 0.25 per day. And BOD of the river water 10 km down. What do we need to find? BOD of river water at 10 kilometer downstream after mixing point. Okay, after the mixing point. See, this is a river, this is a stream, wastewater stream. So it is having QW is 2 meter cube per second and L0 is 90 mg per liter. Here for river QR is 12 meter cube per second and L0 R is 5 mg per liter. So at this point, after this point, the discharge of the river will become 12 plus 2, 14 meter cube per second. This is the discharge after this point, and the cross sectional area is 50 meter square. So this is the mixing point from here at a distance of 10 kilometer, somewhere here. So somewhere here, what is the BOD? What is the BOD of the river water? First of all, once these two mixed up, so the river water BOD will rise because of the wastewater BOD. So what is the BOD of the mixture? What is the L0 of the mixture? It is equal to QW L0W plus QR L0R by QR QW plus QR So by doing this, we will get the BOD mixture. So what is the BOD mixture? First we need to find the BOD mixture. BOD mixture is equal to QW, that is 2 meter cube per second to 90 mg per liter plus 12 meter cube per second into 5 mg per liter by 2 meter cube per second plus 12 meter cube per second. So this is the BOD of the mixture. That is equal to 17.14. That is equal to 17.14 mg per liter. That is equal to 17.14 mg per liter. Now we have got BOD. So this is L0. Now this is L0. So we want LT. So here we want BOD. That is BOD of the river water. BOD of the river water remaining or BOD consumed. So BOD is asking. BOD means what? BOD is equal to L0 into L0 into 1 minus e to the power of minus kd into T. That is nothing but, here it is deoxygenation constant, so we need to take it to the base 10. It is rate constant, then we will take it base E. It is deoxygenation constant, so we need to take the base as 10. So BOD at any point of time T is equal to L0 into 1 minus 10 to the power of kd minus kd into T. So we know L0, we know kd, it is also given. What we need is T, time. So the river is traveling from this section to this section. The distance is known. If you know the velocity, we can find the time. So velocity is nothing but, we know the Q. So Q mix is equal to 14 meter cube per second, which is equal to area into velocity of the river, which is equal to 50 meter square into velocity of the river. That implies velocity of the river is equal to 14 meter cube per second by 50 meter square. So this will be the velocity of the river. How much is the velocity now? The velocity of the river is equal to velocity is 0.28 meter per second. 0.28 meter per second. This is velocity. This is velocity. Now S is equal to Vt. That implies T is equal to S by V. S is equal to 10 kilometer. 10 into 10 to the power of 3 meter by 0.28 meter per second. If you do that, we will get the time. So time is equal to 10 into 10 to the power of 3 meter by 0.28 meter per second. Okay, 10 to the power of 4 meter by 0.28 meter per second. So that will be time is equal to, so this is in seconds actually. If you convert into days, so T is equal to, we are getting the T value is equal to 35714.28. 35714.28 seconds. That is nothing but by 60 by 60 if you do, by 60 into 60 if you do, then it will become into days. It will come in days. So that is 9.921 days. 9.921 days. Okay. So this T is nothing but 9.921 days. 60 into 24. So second by 60, that is minutes. Minutes by 60, that is hours. Okay. Then into 24. If you do this, we will get 9.921 days. So now we got T also. So BOD at a 10th kilometer will be L0 is how much? 17.14. 1 minus 10 to the power of KD is how much? 0.25 per day. 0.25 per day into 9.921 days. So this is the answer. This will be the answer, which is equal to 15.7 mg per liter. 15.7 mg per liter. 15.7 mg per liter. So this is the answer. So let us go to the last question of this topic. Question number 6. GATE 2017. GATE 2017. GATE 2017. One mark, set 1. 1 mark, set 1. Last question. The wastewater from a city containing a high concentration of biodegradable organics is being steadily discharged into a flowing river at a location S. If the rate of aeration of the river water is lower than the rate of degradation of the organics, then the dissolved oxygen of the river water, see here what he is saying, a wastewater, so we are sending wastewater steadily into a river. So this is a river, so we are sending the wastewater at a point S. Okay. Now at the location S, if the rate of aeration, so that is Kr, rate of aeration of the river water is lower than, it is lower than rate of degradation. Degradation of organic matter is nothing but degradation of oxygen. Then the dissolved oxygen of the river water. So dissolved oxygen, what happens to DO? When Kr is less than Kd, that means more oxygen is being depleted. Then what happens? Then the dissolved oxygen of the river is lowest at the location S. No, it's not correct. Is lowest at a point upstream of the location of X. It is also wrong. Remains constant all along the length of the river. Wrong. Is lowest at a point downstream of the location of S. That is correct. See, this is the location where we are sending the effluent into the river water. So this is upstream. So if the river flow is in this direction, so this is upstream, this is downstream. So there is no degradation on the upstream. So there won't be any oxygen deficit will be there on the upstream. And immediately after mixing with the river water, suddenly oxygen will not deplete. So oxygen depletion takes time. It gradually depletes and becomes minimum at some location in the downstream. That is what we have explained in the self-purification process. If you go back and look at the self-purification of river, you will understand this concept very easily. So the option will be option D. That is the answer. Okay. So these are the questions from the previous gate. Okay. So we have completed the disposal of sewage effluent topic. So what we will do, we will start the solid waste management in the next session. So I am concluding it here. We will freshly start the solid waste management topic. Thank you so much.